All right, happy Monday. You should have gotten an email from me yesterday with good news that we are not going to have a test on Wednesday. We're going to actually skip test 15 and just have test 16 next week and just do a homework quiz at the end of this week. So you're welcome. We only have 2 weeks of school left. So excited. But we're going to keep going in lesson 77. We're just going to get to 80. So it's amazing. I'm very excited. So today we're going to talk about lateral area, surface area, and volume of cones. What is a cone? Well, the book's definition of a cone is a three-dimensional figure with a circular base and a curved lateral surface that connects the base to a point called the vertex. So it's kind of a circular base that goes up to a point. Okay, we've seen these. There are party hats, and you've seen a cone, an ice cream cone, turn it the other way. We put snow cones in them if they're turned the other way. So a cone. We need to talk about some particulars about this cone. The base of the cone. The circular face of a cone. What is the base of the cone? It's the circle at the bottom. It actually says circular, so I'll probably write that. Circular face. Okay? So it's this part right here. This is the base. Okay? The vertex of the cone. So the vertex of the cone. The vertex of the cone is the point opposite the base. So where is the vertex? Right up here. This is the vertex. The vertex of the base. Now the altitude of the cone. The altitude of the cone is the height. Altitude, remember, means the height. But it's very specific. It's the perpendicular segment. So I'm just going to write the perpendicular sign. Perpendicular segment from the vertex to the base. Okay? So it must be perpendicular. Now, another thing, so they draw, not that great, but little dotted line comes down at a right angle. Maybe I need to do that in a different color. Okay, so it's this little dotted line that comes straight down to the center. Well, here's the thing. It doesn't always have to come down at the center. Okay, if it is a right cone, scroll down just a little. Maybe keep that up there. If it is a right cone, okay, probably right cone. The altitude will hit the center of the base. Meaning it will hit the center of the circle that is your base, okay? If it is an oblique, Q-U-E, cone, it just means it's tilted a little. We'll use all the same formulas, okay? Then an oblique cone, the altitude does not intersect or hit the center of the circle. Not hit the center of the base. Okay? Oblique just means it's tilted a little bit. We'll still use all of the same formulas. Okay? Now, also in this, we have a slant height, just like we had in pyramids. Okay? The slant height of a cone is going to be this line right here. Oops, sorry, I just dropped my pen. pen. That is going to be your slant height. Okay? And the radius of the cone is simply the radius of the circle. So it's this little dashed line from the center out. That is your radius. I don't think we need a definition of a radius. Okay? So now get your little blue books out or add these to wherever you keep your other formulas. Okay? Because you need it. So we should be starting a new page. So there's nothing written on your little book at this point. Okay, so there's a new page in your book after you turn it. And so at the top we're going to write cones. Okay? Cones. We're going to talk about the lateral area, the surface area, and the volume of cones. So my lateral area will equal pi r L. And if you did not add L to your key before, when we did pyramids, add it now. What was the L? Yeah, it's the slant height. So it says the lateral surface area L of a right cone is given by this formula where R is the radius of the cone and L is the slant height. Okay? So I think pi r H, but H, it's not the H, it's not the actual height. It's just the lateral area. So it's the area of that circular pyramid type, just that side. Okay? And the surface area is simply the lateral area plus the big B, which is the area of the base. What was the area of the base? Pi r squared, because it's a circle. So if you need to write pi r L, which is the lateral area, plus pi r squared, that is just your surface area. Okay? And last but not least, we're just going to finish writing the last one, the volume. Okay? The volume is going to be 1/3 the area of the base times the height. Now that height has to be perpendicular. It has to be from the inside. Okay, so we might have to find that on our own. Okay, so after this, you've written this in your book. We'll have one more to write on the other side before we're finished. And that'll be the end of our little book. If you want to keep it forever, you can. If you want to throw it away after your last test, generally I'm okay with that. But you might need it somewhere. I'm not sure where yet. So let's work some problems, okay, before we're done. Calculate the surface area of a cone in terms of pi. Okay, so I'm going to go ahead and write that in terms of pi. Okay, if the slant height is 5 centimeters, and the base radius, so the radius, equals 4 centimeters. Okay, can you find the surface area? Okay, let's see if we can. So here we go, find the surface area. So what was our formula for surface area? S equals L plus B. And at this point, I like the formulas. Instead of that, I like pi r L plus pi r squared. Right? Do we have everything we need? Yes, we do. I think we do. So here we go. So pi, what is r? 4. Excuse me. And the L, the slant height, is 5 plus pi, not have parentheses there, times. Now, I generally don't do this during class, but I will have a sneezing fit to where I will sneeze 32 times possibly before I stop. So, I apologize. Just allergies are killing me. So, it says in terms of pi. So here we have, do I need to simplify this? Yes, pi times 4 times 5 is really 20 pi. Okay? And then I need to square 4. 4 squared is 16 times pi. Okay? Can I add 20 pi plus 16 pi? I asked this question. Can you add 20x plus 16x? That answer is yes, so you can add 20 pi plus 16 pi, and you get 36 pi. Now, it's area. Do I need to talk about units? Should I have centimeters squared? Yes, you should. Okay? You've just found the surface area. Wonderful. We can do this. We can find the lateral area and the surface area. Now, what if we wanted to know, well, what is the volume? I'm going to keep the same problem and say, can you find the volume of the same cone? Okay? Now, at this point, what's the formula for volume? Let me know. V equals 1/3, because we just wrote it down, area of the base times the height. Now, area of the base, we've already found, right? This is my big B. So here we go. We have 1/3, area of the base is 16 pi, times, now what about the height? What about the height? I'm going to have to find that out. So I'm going to the side in my little bubble, and I'm going to draw a cone to the best of my ability. And I know something about this cone. I know its radius from here to here is 4 centimeters. And I know the slant height. Where was the slant height again? On the outside. So this line right here is 5 centimeters. How in the world can I find the actual height? This part right here. Height of the cone. What is drawn inside that cone? Do you see it? With this blue dotted line, that's the height and the radius. And then this part right here, it has to come down perpendicularly. So what do we have? All right, triangle, exactly. So can I solve for the height? H squared plus 4 squared equals 5 squared. Pythagorean theorem. If I had so many times, it comes back to the Pythagorean theorem. Imagine that. So H squared will equal 25 minus 16, which I believe is 9. So H equals 3. So my height is 3. You probably recognize that as a 3, 4, 5 triangle. Of course, my cone is not drawn to scale, so I apologize. So, what is my H again? 3. So, what is 1/3 times 16 pi times 3? If I'm leaving it in terms of pi, just simplify. I'm going to scroll down just a little. Can we simplify? What's 1/3 of 3 over 1? It's just 1. 3 divided by 3 is 1. The volume is 16 pi. Right? We have centimeters cubed. And you've done the volume. So sometimes when you're finding the volume, you have to find the height. You're going straight down perpendicular. Use the Pythagorean theorem to find the height if you need it. Or if they give you the height, could you solve for the slant height? Yes. As long as you have 2 of those 3 pieces, you can solve it. All right. And that's it. We're done. Short, nice little lesson. We're going to do a few problems. So from lesson 77, we're going to do the practice. And numbers 1, 6, 11, and 12. All right. Nice short lesson for a Monday. I'll talk to you later.